Okay, welcome to lecture 23. So we've already done P4, and we have to now finish placing our symmetry elements. Now we had done, if you recall, P2MM by inspection originally, but now we're going to formally just, say, hey, we did P4, now let's insert these two mirror planes, and let's see if that's compatible with this lattice. And you have to insert two of them. Well, you have to insert two of them that are the same, and the question is, what else do you end up with? So let's do that out now. If you recall, we had the following. I'll try to make a square here. These are the outside standard cell vectors, and we have, in the case of P4, we're starting with these symmetry elements that we had already derived from our other combination theorems, etc. So there's P4. Now, we know that if we put mirror planes in at the edge of the cell, the fourfold means I have to have a mirror plane going across, like that. Again, remember, these combination theorems are essentially created to help us identify, what's happening without needing to rederive this each time. And recall that if tau is 0, then it's just a reflection plane, and we have the generic case of producing another specific case of this theorem. Related to this, passing through here, once you do a 4mm here. And so I have these mirror planes that are also passing through the standard cell like that. And you can see that with the motif again right here, right? Reflected across that plane, and vice versa this way, right? Okay, so now that I have these mirror planes, and I have these mirror planes, different mirror planes, right? Which is why it's M, right? The question is there anything else that I haven't noticed in this lattice? Now, symmetry elements. And so one thing immediately you could say, well, with all these mirror planes, we already solved pretty much. We know what on each one of these points it does, but what about any additional glide planes, for example? So if we look at this lattice, this pattern. Let's get this line right here. So this one half t1 plus t2, and remember what we're looking at therefore is if we take the generic case of a mirror plane intersecting these translation vectors, I have this one, and I've got remember this is a full translation vector t, over there. So we can then look at this as this one can be t perpendicular, right, because I have mirror planes and this translation vector perpendicular to it, right? And that's a very specific subcase of this, remember. And half the distance of t perpendicular is going to be here, right? So, we would expect that specific case of consider this to be number 1. It's reflected across the plane. Here, glide plane here, and the glide plane here. So in general, what you see, just to clear this up a little bit, well, is that if you recall, we had that fourfold axis, and we had the one mirror plane passing through there and one through there. Notice how typically if you have what the theorem really says, if you do that, then in between the two mirror planes, you'll generally expect to see glide plane. And P4MM was relatively difficult to see, but after we drew in the motifs and you saw the other mirror planes, and you knew that it was there. So what we should be doing kind of is with that in mind, picturing that as you have mirror planes in parallel on a lot of these other, as we form other patterns, that between the mirror planes you'll have a glide plane typically sitting in the middle.